Don't even take my quizzes. I don't care. Am I giving you bad advice? Yep, I'm giving you bad advice. Take everything seriously. All right. So here's what we want to do. We want to find the range. We want to find the mean. We want to find the variance. And we want to find the standard deviation. And these set of numbers, this is based off a population. So we're going to go ahead and proceed as a population. So let's begin with the range first. What's the range? The range is the maximum number minus the minimum number. So what's the biggest number? What's the smallest number? 4. So we have 8. That's it, you're done. So nobody should get the range wrong, unless you obviously, if you misidentified the biggest and smaller, you got it wrong, but that's your problem. All right, so now we're gonna do the mean. So the mean, I'm gonna go ahead and use the symbology for it. Here's the mean, the population mean. We use the letter mu. All right? So the mean is defined as a sum of x divided by capital N, denoting that we're dealing with a population. The big N is the big N we use, or the uppercase N we use to denote that we're dealing with a population. So you're going to take 12 plus 9 plus 7 plus 5 plus 7 plus 8 plus 10 plus 4 plus 11 plus 6 divided by, how many numbers do we have there? We have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the rest is just, you compute your numerator. 12 plus 9 plus 7 plus 5 plus 7 plus 8 plus 10 plus 4 plus 11 plus 6. Let me count the numbers, make sure I didn't miss one. That's 79. $7.9. So we found our mean. Yes. Am I going to be picky about you using mu? I think I should start very soon. I should be like, hey, use mu when it's appropriate, use X bar when it's appropriate. And the question I'm answering, do we have to get this notation down? Should we be using the proper notation? The answer is, yeah, you want to develop some sort of mathematical consistency, some sort of maturity. And so if I'm doing it, maybe it's time for you to do it. Maybe. So now we're going to compute the variance. So the formula for the variance, for the population variance, remember, this here's a population mean. This is going to be the population variance. And so the population variance is the sum of x minus mu squared divided by n. So it means find your deviation, which is x minus mu, square each of the deviations, which will make them positive, all of them will be positive, and then add them all up. And after that, you divide by the total amount of numbers. So this is the average of the squared deviations. This is what this is. This is a type of average. All right. So what do we do? Well, there's various ways of doing this. For now, I think you should start doing a chart, but you don't have to do a chart. You can do it on your calculator if you like. All right. I'll do it both ways. Let's do the chart first. So let me scroll up the board up there so everybody can see. So the first thing you do is you create the categories, you know, the X's. Right? And so we have the following numbers. We have a 12. We have a 9. We have a 7. A 5 and a 7. We have an 8. We have a 10. We have a 4. An 11 and a 6. Okay. So now we've made a listing of the numbers. Don't miss any of the numbers. The next step you're supposed to do is you're supposed to find your X minus your mean. These are our deviations. These are our deviations. Let me give myself some space here. So you're supposed to take 12 and subtract, what was the mean? 7.9. And then you take 9 and subtract 7.9. And you take 7 and subtract 7.9. And you take 5 and subtract 7.9. And you take 7 and subtract 7.9. And you take 8 and you subtract 7.9. And 10 and subtract 7.9. And 4 and you subtract 7.9. And 11 and subtract 7.9. And 6 and subtract 7.9. Right? That's what you're supposed to do. That line I made I should have a little bit more space. I should have made it after. Let me erase it. There we go. Restroom, yes, go to restroom. Be careful though. All right, so 12 minus 7.9, that's 4.1. Let me make it bigger there. I don't want 4.1. 9 minus 7.9. That's a 1.1. 7 minus 7.9. That's negative 0.9. 5 minus 7.9. That's negative 2.9. 7 minus 7.9. That's negative 0.9. 8 minus 7.9. 0.1. 10 minus 7.9. That's 2.1. 4 minus 7.9. That's negative 3.9. 11 minus 7.9. That's 3.1. And 6 minus 7.9. That's negative 1.9. Now, I should check right now that my deviations add up to 0. Now, when we have a nice mean now. We didn't have to round our mean, but sometimes when you get a mean, you round it. And then when you do the sum of the deviations, it doesn't give you exactly 0. But in this case, our mean wasn't rounded. So if we take 4.1 plus 1.1 minus 0.9 minus 2.9 minus 0.9 plus 0.1 plus 2.1 minus 3.9 plus 3.1 minus 1.9. It should give me 0, and it does. So the sum of our deviations is 0. So the next thing you do is you have to square your deviations. Square your deviations to make them positive. So 4.1 raised to the second is going to be 19.36. So you write 19.36. Now, because I'm teaching this for the first time, I should write here, hey, we're taking 4.1 and we're squaring it. And it should be 19.36. And you take 1.1 and you square it. That's 1.1 squared is 1.21. And then you have negative 0.9, and make sure it's in a parentheses, raised to the second. All these numbers should come out positive. So if in your calculator you make a mistake and you just put negative 0.9 squared, the calculator is not going to multiply negative 0.9 times negative 0.9. It's going to take 0.9, square it, and then apply the negative, and you're going to get the wrong answer. What did it give you? Oh, because I put the wrong, thank you for spotting that. I put 4.4 by mistake. It's 16.81. I'm sorry. Thank you for spotting that. So 16.81. So negative 2.9 squared, 8.41. Right? Then you have negative 0.9 squared. That's going to be 0.81. 0.1 squared. (2.1 squared). Negative 3.9 squared. I mean, it takes some time to do this, and it could be error prone, especially when we start adding, because we're putting a lot of numbers in, and who knows if you add or subtract depending on your calculator, and you gotta be careful. 9.61. And then you have negative 1.9 squared. And that's going to be 3.61. And now you've added everything. Now you've found everything. So now your next step is to add all these up.
Teachers and students, please pardon this interruption. Students that paid for homecoming, last names A through E, please report to the hallway going to the media center to pick up your ticket. Thank you.
All right, 16.81 plus 1.21 plus 0.81 plus 8.41 plus 0.81 plus 0.01 plus 4.41 plus 15.21 plus 9.61 plus 3.61. I got 60.9. So the sum of my deviations squared equals 60.9. This is referred to, let me scroll up for you guys. This is referred to as our sum of squares. This is referred to as our sum of squares. S of x. Okay? So we go to our formula. Our formula for our population variance is our variance, which is sigma. This is lowercase sigma. See, the one we use for sum, this guy here is uppercase sigma. So lowercase sigma must equal the sum of my deviation squared. In other words, this here divided by the amount of numbers I have, or the size of our set of numbers. So that's going to be 60.9 divided by 10. So that's going to be 6.09. Now, remember that our population, I don't know why I'm jumping ahead like that. Our population standard deviation will be the square root of our variance. In other words, since we squared everything, we squared all those numbers, the way we get rid of squares is we square root. So we're going to go back to what we wanted initially, because remember, we wanted to get the average of our deviations, but when we added our deviations, it came out to 0, so no good. So we squared all these numbers to make them positive and added them up together and divided by a total, so we get an average of the spread of the square root of the deviations. And so now we want to get the average distance, not of the deviations, but of the numbers, then we should square root. So it's going to be square root of 6.09. And usually you're gonna round this if it's not a nice number. We can talk about rounding at another time. Square root of 6.09, and it comes out to approximately 2.47. So you found the range, you found the mean, you found your variance and your standard deviation, and you're done. Yes. So, what's the big deal about the sample? So what I'm going to do is I'm going to go back to the original numbers. So let me scroll up here on the board. All right. Now I'm going to go ahead and do the same problem before a sample. All right, so let's say at the beginning of this problem, I would have defined these numbers as a sample instead. As a sample. So the max minus the min is the same. It doesn't matter. Now I'm going to call this a sample mean. Sample mean. So instead of mu, we use now X bar. Instead of capital N, it's lowercase n. It's the same calculation. Same calculation. Nothing changes with the calculation. So now let's talk about the formula for the sample variance. For the sample variance, we no longer use lowercase sigma. We use S. So S squared equals the sum of X minus not mu, but minus X bar, and then divided by n minus 1. This is our formula. The only thing that's changed between the population variance and the sample variance is that we subtract 1 to the n. So now let's go to the table we made. Let's go to the table we made. So what changes in our table? Well, you still got the same mean, so your deviations didn't change. This now is just x minus x bar. When you add up all these numbers, you're still going to get 0. Let me make that prettier. You're still going to get 0 when you add up all the numbers. When you square the deviations, you get the same number. You still get the same sum of squares. Oh my gosh, you saw what happened there? You still get the same sum of squares. Okay. So what changes? What changes is what happens here. So we have our sample variance. This is an S. So S squared. This is going to be n minus 1. So this is going to be what? 60.9 divided by, instead of 10, you're going to divide by 9. So 60.9 divided by 9 is 6.77 approximately. Obviously, you should keep this in your calculator. In other words, if you kept the number in your calculator, when you did the square root here to find your standard deviation, it's a sample. So you would take the square root of 60.9 divided by 9. That's what I would do. Because you can use 6.77, but 6.77 is rounded. I mean, the number in your calculator is probably rounded too, but it's more accurate. So I'm going to go ahead and say the square root. Oh, give me 1 second. I'm not used to this calculator. The square root of the number you kept in memory, the full number. And now you get approximately 2.601, whatever, 2.6. And so that is how you do the sample standard deviation. It's the same thing as the population standard deviation, except that when you're finding your variance, you're gonna divide by 1 less than the total amount of numbers. So in a nutshell, that's the measure of a variance. Okay. That's how you get the spread. The smaller that number, the smaller the spread. Okay. This number must always be positive. Make sense? Yay, nay? That's it, guys and gals.